Okay, good morning, everyone. Today we're going to continue our discussion on multiple linear regression. What we have discussed so far was we looked at the wage data set. Let me just remove this. Okay, and we learned that if you're working with a project, so here we are. We created this project last time, multiple linear regression. And in this project, you have the files that we have been working on. Included in that is the wage data set. So it will be very easy for us to access this data set. Okay, you just make use of the read_CSV, which comes from the readr package, which is part of tidyverse. So let me just load this data, this package. So once it's loaded, the readr package comes with it already. So you can use this read_CSV, wage that CSV, which is your file, and no need to identify the file location because it's already loaded in your working directory in your project, our project. So it's always a good idea to create projects, and in those projects you put the files there that are relevant to your specific project. So let me load this now, and you can see now here we have our wage data set. So very quickly, let me access this. So we have 8 variables. The variable of interest to us is hourly wage. This is our dependent variable, and we'd like to predict hourly wage based on these parameters. And we learned last time that there are 5 variables here that are, 4 that are numeric, and then 3 that are categorical. Okay, and last time what we did was to look at the relationships between hourly wage and the other variables, and we said that we would like the independent variables to be highly correlated with your dependent variable, but not the independent variable correlated with your other independent variable. Otherwise, we will have what we call a multicollinearity issue. Okay, we will deal with this when we do diagnostics. So quick review, what we did last time was just to learn how to do a simple linear regression. Okay, how did we do that? We said that to do a simple linear regression, we just have to, let's see, I think it's here. All right, this one. We created this model mod1, and we use the linear model function where we are regressing hourly wage. This is your dependent variable on education, and we identified the data. Okay, so we learned about this last time. So quickly, I now have this model1 here, model1 object, and it's a list. It contains several items with it. You can, of course, get the summary, or you can, if you want straightforward to generate the results, Control-C, Control-V, you can use this function, summary, combine summary and the model. Okay, if we combine this, summary and then the model, you'll generate automatically the summary output, this one. Okay, so we have here details about, first is the formula, and then the residuals, which is very important. Later on, we're going to discuss in greater detail diagnostic test, because it's not enough to generate a model. It's also important to see if our model is valid by looking at the residuals. And then we learned about this education. It's statistically significant. 3 stars means it's significant at the level of significance of 0.001 here. Okay, which is equivalent to a level of confidence at 0.099. Okay, level of significance is 0.001, and then 1 minus the level of significance alpha is equal to your beta. So let me just write that alpha. Okay, maybe let me see. Okay, anyway, alpha, which is your level of significance, right? And the usually what's significance, what's used is 0.05. Okay, of course, this will generate an error because it's not a command. So alpha is a level of significance. On the other hand, beta is the level of confidence. And it's equal to 1 minus your alpha. Okay, so it's here we're stating that we are 99%, okay, or 99.9%, because our alpha here, we are significant at 0.001, which means our confidence is at 99.9%. We are 99.9% that our education is not equal to 0. Okay, because this is what this means. The null hypothesis here, if you recall, based on our discussion, is that beta 1 is equal to 0. And we reject that null hypothesis. All right, and then we discuss the meaning of this. 0.54 means for every 1 unit increase in education, and in this case, it's 1 year, for every 1 year increase in education, there's a corresponding 0.54 centavos, or sorry, $0.54 or 54 centavos increase in your hourly wage, yun ceteris paribus. Okay, the intercept is the value of your hourly wage when all your independent variables are 0. So this means that in this case, since we have only simple linear regression, education is 0 years. Okay, so we said that although it's not significant, we still include that in our model. Okay, so for example, in your exams, you have to include your intercept, even if it's not significant. Okay, only for the intercept. And then we discuss this. The R squared. This tells us that what does this tell us? 16.48% of the variation of the variability of your dependent variable hourly wage can be described by our model, ceteris paribus. Although here, ceteris paribus does not make sense because we only have one predictor. Now, where did we get this? 524 degrees of freedom. Okay, that's very easy to find out. Okay, are how many n row of wage? How many observations do we have? We have 526 observations. Okay, then for the F test, you have 2 degrees of freedom. DF, the first degree of freedom is equal to 1, which is this is the degree of freedom lost because we're computing for the intercept also. Okay, it's 1. If we indicated that we don't want to, because we can actually come up with a model where there's no intercept. Okay, so let me just quickly show that to you. If we placed here, okay, 0 plus. What if we do this? 0 plus education. This means that we don't want education to be, this means that we don't want the intercept to be part of the model. So let's just show this. All right, so we can see now here that there is no intercept here, right? Wala nang intercept dito. Si education na lang lumabas. Okay, and how was this generated? Inad lang yung intercept at saka yung slope ng education. And then you can find here now that there are 525 degrees of freedom kasi hindi na sinama si intercept. Okay? Because by including intercept in your model, you lose 1 degree of freedom kasi i-compute mo pa yung intercept. Okay, ngayon, ang nangyari na lang, degree of freedom 2. What's the degree of freedom 2? Degree of freedom 2 is equal to n minus k, okay, n minus k, and if there's an intercept, okay, technically it's n minus k minus 1 kung kasama si intercept. No? Pero kung wala si intercept, so 0 to, n minus k, k refer to the number of predictors. Okay, the number of predictors is only education. So if there are 526 observations, so that's 526 minus 1, which is the number of predictors, so you have 525. Okay, I know I'm talking too fast. Let me pause for a while. Any questions about that, class? So please feel free to ask questions, class. Paki-chat na lang kung clear tayo so far so that I know if I continue. Clear ba tayo, please? Okay, good. Good. Thank you. Sige, salamat ha. Salamat, class. Now, take note, class, you can impose that the intercept should not be part of the model. But usually, sinasama talaga natin siya. Kaya wag na natin, ibalik natin sa model natin, na model 1. Okay? So we have here, balik tayo dito, no? So we have the intercept. And then if you add the intercept and the education, you get the slope kanina, no? 0.4 something. Okay, that's what we generated a while ago. All right, thank you. Thank you for those feedback. All right, so let's now go here. Remember, this is the test of the individual means, no? Individual t-test. Each of the parameters we're testing for its significance. Ito naman, what do you call this, class? This is the overall goodness of fit test. So the null hypothesis here is beta null is equal to beta 1 is equal to etc. Depending on the number of predictors is equal to 0. So in this case, we reject that null hypothesis that beta null is equal to beta 1 is equal to etc. Okay, because the p-value is very, very small. So we said that when the p is low, the null must go. Okay, now we have here multiple r squared, 16.48%, and adjusted r squared, which we will discuss this in the context of a multiple linear regression in a while. Kasi gusto natin malaman, paano na-compute tong multiple r squared na to? At saka paano ma-compute tong adjusted r squared na to? No? It will be good for us as students of finance to really know, kumbaga parang doktor tayo dito, no, na bawat point dito naintindihan natin, alam natin kung saan gagaling. Okay? All right. Yung residual standard error, okay, by the way, class, I recorded a video on matrix, no? Ito, pakita ko lang sandali ito. Hindi yata ito yung file. But I solved itong wage data set natin, okay, using our matrix, and we will get the same results, no? But it's important for us to know that yung sinusolve to ng R based really on matrices. Kasi dati wala naman mga powerful computers, kaya ito talaga yung pinanggagamit kasi this is the best way to do it, no? Matrices. However, we will not go into the mathematics of this, but suffice it to know, class, that the parameters, yung beta null and beta 1 natin, can be solved using this X transpose X inverse X transpose Y. Okay, so it's important, class, as students of finance, na alam din natin yan. Hindi tayo papayag na, sorry to say this, na UP students lang or Ateneo students lang nakakaalam yan. No? As Lasallian, where we have quality education, aalis tayo sa institution natin na kahit paano naiintindihan natin kung saan nanggaling yung mga yung mga solutions yan. Okay? All right. So let me go back here. Okay, balikan na natin yung model natin. Where am I? Okay. So let's now work with a multiple linear regression na tayo, no? All right. So going back to our data, let's take a look at the structure of our data. So alam natin na may character dyan, no? Character. Now, when we regress hourly wage on race, gender, and civil status, R will solve that, no? Tapos makikita natin ngayon kung paano i-interpret yung mga categorical variables as regressors. Pero it's always good practice, lalo na kung hindi naman masyado marami, to convert. I-convert natin yung yung mga variables natin, no? So how do we convert race into a factor? So number one, wage natin si race. Let's do it one by one na lang, no? As that factor, no? As that factor. There. So sinasabi natin yung wage, yung race, the variable from wage, should be converted as factor. So wage, raise. Okay? So Control Enter. All right, and then we do the same for the others. Control C, Control V. This time, raise, ano pa yung susunod? Dollar, si gender. So, gender to. And then yung huli, dollar is gender, civil status. Dollar, oops, civil status. Okay. So what are we doing here? We are converting all our character variables into factors. Okay, sabi natin, pag factor kasi, pag character lang kasi, hindi pa pwedeng magamit as regressor yan. Okay, although, ngayon, nagdi-default si R na kahit ng characters, automatically niya kino-convert into a factor. But it's important for us to know how it's done. So ito, i-run natin lahat. Okay, and then let me go back to the structure of wage. And we now can see that these three parameters, these three variables are now factors. Okay, tignan nyo, no? Si race factor na siya with 2 levels, non-white, tsaka si white. Si gender, 2 levels, then female, at tsaka si male. Tapos si civil status factor din with 2 levels, married and single. Okay, now, what will be done with this? I-convert siya into what we call dummy variables. So it's important for us to know what dummy variables are. I-annotate ko na muna to. So what will happen behind the scene is that R will convert our factor into a dummy variable. Dummy variable. So for example, tingnan natin si race. No? Ang default ni R ganito. Tinitingnan niya non-white tsaka white, no? So which will alphabetically appear first? Mag-a-appear muna si non-white. So ito gagawin niyang 0. So lahat ng non-white gagawin niyang 0, lahat ng white gagawin niyang 1. Yung ginawa niyang 0, ang tawag natin dyan, benchmark variable. Benchmark. You'll see why it's called benchmark. Okay, dito naman kay gender, sino yung benchmark niya? Si female. Bakit? In order of appearance yan? No. No, it's not according to order of appearance, it's according to alphabetical. So since female will appear first before male, alphabetically, no? So gagawin niyang benchmark to 0, tapos si male 1. Tapos ganoon din si married at saka single. Si married will become the benchmark variable 0, and then single will be 1. You can reverse it, no? Pwede natin baguhin yan, but let's not. Let's just use the default first. If you want, for example, si white yung benchmark, pwede rin. Pwede yan. Okay. Question. Si race, dalawang level siya, di ba? White at saka non-white. Therefore, ilang dummy variables yung ma-generate sa kanya? How many dummy variables? Anyone? Okay. 2, Jonas. Thank you, Jonas. Okay. Jonas minus 1 pa. Jonas? Yes, thank you. 1 dummy variable lang. Bakit? Pakita ko Okay. Why? Bakit 1? So, ang mangyayari dito, di ba itong si race, i-convert niya, no? Gagawin niyang dummy variable yan. Paano magiging dummy variable? Okay, urong ko lang ito para... Yan. Okay. So, papalitan niya itong race. Kasi si race, character yan di ba? So, ang mangyayari niyan, race. Okay. Sino yung ano natin dito? Si benchmark? Si non-white, di ba? Kasi si non-white yung alphabetically mauuna kaysa kay white. So, lahat ng white gagawin niyang 1, 1, 1, 1, 1. panay 1 dito lahat, ano? Kasi panay white yan eh. Pero when we go here, okay. When we go below here, may mga non-white dito, ano? Ito. So si non-white na yan, magiging 0 yan. So that's what I was saying na lahat ng non-white gagawin niyang 0. 0. Okay? Lahat ng white gagawin niyang 1. So ilang dummy variable to? Isa lang, no? Isa lang to na dummy variable. Look. Because this one dummy variable was already able to account for all the values of your race. Diba? Accounted ba si white? Yes. Lahat ng 1, white yan. Accounted ba si non-white? Yes. Lahat ng 0, non-white yan. Okay, so yung dummy variables na i-introduce will be k minus 1 dummy variables. Ano yung k minus 1? K refer to the number of levels. Okay, number of levels, in this case, ang number of levels natin dalawa. White at saka si non-white. Diba? So kung dalawa yung levels natin, 2 minus 1, that will only be 1 dummy variable. Okay, suppose we have a variable, no, year level. Year level. Okay, suppose we have, meron tayong frosh, meron tayong sophomore, sabihin natin SO, meron tayong junior, meron tayong senior SO. Okay, this is a, sabihin natin, character variable siya, tapos kinonvert natin to a factor. So, ilang levels to? Ilang levels? Unmute na lang please, para, anyone please, ilang levels to? Frosh, sophomore, junior, senior. Pwede pa natin dagdagan ng graduating, pwede rin. Pero let's just focus on 4. Anyone, please? Ilang levels to, class? Hello? How many levels? Okay, may sumugod ba dito? Okay, Bruce, bakit 5? Bruce? You can unmute yourself.
Sir, I think kasi 5 yung categories.
Pakibilang. Frosh,
Frosh,
sophomore,
sophomore,
junior, and then Bruce.
senior, saka graduating, sir.
Okay. Sorry, hindi ko na sinaming graduating. Sabi ko hanggang senior lang.
Sir,
So,
4.
kung kasama si graduating, tama si Bruce, 5 yun. No? Pero kung frosh, sophomore, junior, senior lang, 4 lang. No? Okay, ang question, how many dummy variables will be introduced? The answer is k minus 1. Ilang levels? 4. Minus 1, 3. Okay, ano ibig sabihin ng dummy variables? Okay, magbigay tayo ng example dito. Let's assume si respondent 1, okay, babalik tayo sa taas kanina. Okay, dali Mahirap i-galaw nito. Asan ito? Yan. Okay. Let's suppose, so may ano tayo dito, ano? Balik na naman ako sa annotate. All right. So this is year level, no? Year level siya. So let's say observation 1 is senior. Tapos example lang to, senior, sophomore, junior, frosh, junior, sophomore, etc. Senior. Example lang to. Kunyari itong mga respondents to, they belong to senior, sophomore. Okay, what will happen now? Paano yung dummy variables ginagawa? So ang sabi natin, there will be 3 dummy variables. Okay? Ang gagawin ni R, 3 dummy variables, and also with other softwares. Saan natin nalaman yung number of dummy variables? It's k minus 1. So dapat alam natin kung ilang levels, minus 1, so 3. No? So ang mangyayari niyan, itong variable na to, papalitan to ng 3. No? 3 variables. Ano yon? So sundin natin si R. Ang pinaka-alphabetically, dito, una, F. Alright? F. So ibig sabihin niyan, F will be the benchmark. So hindi na natin kailangan maglagay ng 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 variable for F. Kasi F will be the benchmark. So ang mangyayari niyan, sophomore, junior, senior. Now take a look what happens here. Ito senior, no? So ang mangyayari niyan, 0, 0, 1. Bakit 0 to? Hindi naman siya sophomore. Hindi naman siya junior. Hindi naman siya, senior siya, kaya 1. So ito din, senior, no? 0, 0, 1. Ito sophomore, magiging 1, 0, 0. Junior, 0, 1, 0. Frosh, 0, 0, 0. Yan. Kita nyo, class? Lahat ng levels accounted for. Okay, so no need to put here an F na magiging 0, 0, 0, 0, 0, 1. Hindi na kailangan yun kasi dito pa lang, okay, dito pa lang na accounted for na si Frosh. No? If you put another variable here, so making it 4 dummy variables, you will magkakaroon tayo ng problema sa regression. We will fall under what we call a dummy variable trap. Magkakaroon tayo ng multicollinearity. No? Eh di ba sabi natin hindi pa pwede may multicollinearity, no? So yung dummy variable trap, that happens when you introduce k levels of dummy variables when it should be only k minus 1. Okay, so tandaan nyo class, kunyari kung 5 yung categories yan, 5 yung factors, the software will automatically just introduce 4 dummy variables. Okay, kung ima-manual nyo siya, tapos mag-introduce kayo ng 5, magkakaroon ng error dun sa model natin. Okay? So si gender, ilang ano to? Si gender, 2 levels lang to. Ilang dummy variables to? Class. Female, male lang to. So how many dummy variables? Hello, class. How many dummy variables, class? Okay, 1. Thank you, Jonas. How about si civil status? Ilan lang yung ano natin? Ilan lang yung, 2 lang to single at saka married. So therefore, isang dummy variable lang. Right? Okay, good. Thank you, Ivan. All right, I hope that's clear, class. No? Importante sa atin. No? Kasi maraming regression class will include factors. Okay? Kasi we will see ano yung interpretation nito, no? In a while. All right, sige, punta na tayo. Let me clear now all my drawings. Close this. Okay, let's go now to our model. Okay, siguro check muna natin yung correlation natin, ano? Okay, punta tayo dito, Control-Alt-I. Okay, para mas mabilis tayo, ikokopya ko na lang yung ano, kasi ginawa ko na to. Okay. Alright, so this is what we did, no? Tapos yung correlation natin, we can use the core function, di ba? Okay, or we can use this. Okay, i-copy ko to. By the way, Control-C. Okay. All right. What did I do here? Take note, yung wage data set natin, merong factors. Eh, hindi naman tayo pwedeng mag-correlation dyan, no? Kasi these are, in a sense, categorical variables. So gusto lang natin makita yung mga numeric variables. So that what we're going to do now is take a look at this code. I'm creating this object wage1, and then it's part of the wage, is a subset natin, negative C4 to 6. Ano ibig sabihin nun? So this is 4th, 5th, 6th, negative, tatanggalin natin. So we're removing yung 4th to 6th column. The row will be preserved, lahat ng rows. Okay, so ang tinatanggalan natin dito yung, tapos i-view natin. View natin si wage 1. Alright, sige. So pakigawa nyo to, class. Alright, then we now have this one. So ito na yung ano natin, ito na lang yung lahat ng mga numerical variables. Okay, we just want to see using the site package, which I think we discussed last time, yung function appears that panel ng wage 1. Okay, so if we do this, lalabas dito, makikita natin correlation. Yan. Okay, so the correlation between education, okay, education and experience is negative 0.3. No? Ito yung plot niya. Ito yung scatter plot niya. So we can see here the different correlations, negative 0.22, 0.5. The only disadvantage of this is that we don't see the significance of this correlation. Kasi numbers lang eh. Kaya mas maganda pa rin yung GG Ally, which we introduced last time. Diba si GG Ally? And then although we did not load this, pwede natin gamitin kasi namespace siya. And then we can use the GG pairs function ni GG Ally. Okay, let's run this. Okay, and then we can see here, similar to the pairs.panels, similar lang, kaso dito, okay, merong merong significance. No? So it tells us here that education, the correlation between experience and education is negative 0.3, and then it's statistically significant. The correlation between education and tenure is negative 0.05. So this is a very small correlation, and it's not significant kasi walang star siya. Okay, so yung may mga stars dito, it tells us that the correlation between these variables are significant. And of course, we're interested also in this one, yung correlation ni hourly wage with education, with experience, with tenure, with number of dependents. Gusto natin, class, yung dependent variable natin highly correlated with your predictors, education, experience. So dito makikita natin na si number of dependents lang ang pinaka hindi correlated. Okay, mababa yung correlation, no? Negative 0.05. And we might suspect that this might not be a statistically significant predictor for hourly wage. Okay, pause muna ako, please. Chat for any questions. Clear ba so far? Okay, good. Thank you. Thank you, Jonas. How about the others, please? I'm quite fast with my explanation, but I hope you're able to follow. And in case na I'm going too fast, in case na hindi maliwanag class, please feel free to ask questions. I can repeat anytime. Okay, waiting for the others to give their feedback, please. Okay. All right, so let's now create Control Shift and Control Alt I. Let's now create another model. Let's call it model 2 kasi kanina model 1. And then we have LM, diba? Linear model, hourly wage will be regressed on, maglagay muna ako dito ng ano. Okay, kunin ko lang muna yung names ng names ni wage dataset. Okay. And then I'm going to copy ko to. Control C. Tapos mag-delete na lang ako. Education plus, so matagal yata to. Anyway. Plus. So we're now going to regress. Gagamitin natin lahat na ng predictors sa model natin. Plus. Then we have to identify data is equal to wage. Yan. Okay, take a look at this first. And another way to do this is you can do this mod 2. I'll leave it as a comment na lang. LM hourly wage regress on all. No? All right. So same lang yan, no? Tilde dot, which means all of the variables will be used to model our hourly wage. Okay, sige, pause muna ako, class. And when you're done, kindly run this. Ilagay na natin sa summary to, Summary para isang ano na lang. Isang run natin. Summary natin si model 2. There. Hey, kindly chat if you were able to run this. Thank you, Jonas. Let's wait for the others. Okay, good. Okay, good. Thank you. All right. So let me run this. Okay. So we can see here our summary output. All right. We have the first, the call to the formula, regress on all the variables. And we have the residuals. And then we have the individual tests. All right. Let's take a look at this. Si intercept, na bago na siya ng value, no? Tapos naging statistically significant na siya. Education, still significant. Experience, the dot here, ano ibig sabihin ng dot dyan? Titingnan natin dito sa reference, no? Dot ito, 0.1. Ibig sabihin, this is statistically significant at 10%. Tinan nyo yung 0.07, di ba? So hindi siya statistically significant at the level of significance of 0.05. Significant siya at 10%, kaya isang dot lang. Others, itong tatlo, di ba? Significant at 0.001, gender male at 0.001. The others are not significant. Okay, so let's interpret this. Okay, first, education. Ano ibig sabihin ng education dito? That for every 1 year increase in education, di ba positive yung ano niya, di ba? Yung beta niya. There's a corresponding $0.57 increase in hourly wage, ceteris paribus. Dito na yung ceteris paribus magiging relevant. No? Ibig sabihin, it's only education that you're increasing by 1 year. The others will remain constant. So hindi natin ipapa-increase yung experience, si tenure, si race, si gender, si civil status, at saka si number of dependents. Okay? So education is a marginal increase niya on hourly wage is $0.57. Okay, how about experience? Okay, assume experience is statistically significant at the level of significance. No? Ang ibig sabihin nito, na 0.02, for every 1 year increase in experience, there's a corresponding 2 centavos or $0.02 increase in hourly wage, ceteris paribus. Okay, I'm assuming that this is significant, no? At 5%. All right, next. Si tenure, ano ibig sabihin nito? Tenure is also in years, so it means, and it's statistically significant, no? It means that for every 1 year increase in tenure, there's a corresponding $0.138 increase in hourly wage, ceteris paribus. Laging kasama si ceteris paribus. Kasi pag tinitingnan natin tong marginal effect ng isang predictor, ng isang parameter, This is just the effect of this parameter and assuming that the others remain constant. So, importante yun. No? Okay. So, let's take a look at race white and this is significant. So, tingnan natin tong gender mean. Okay. Ano ibig sabihin nito? Di ba factor to, si gender male? What is the meaning of 1.76? Approximately $1.76. Okay, the meaning of this is that, remember, si gender male, di ba, this is a dummy variable. Sino yung zero dito? Si female. Si female yung benchmark. So when we interpret this, it's always in relation to your benchmark. So how do we interpret this? On the average, the male respondents in this survey received $1.76 hourly wage more. Positive siya, more than their female counterparts. Okay, let me repeat that. And then ceteris paribus wala, no? So, ang ibig sabihin nito, on the average, si male respondents of this survey received $1.76 more than their female counterparts. So, ang factors class always interpreted in light of their benchmark level. Okay? Okay, let's assume class this is significant, no? Si race white kasi hindi significant eh. Pero if this was significant, how would we interpret this? On the average, white people dun sa survey natin receive around 11 centavos more than their non-white counterparts, ceteris paribus, no? Assuming it's significant. And then here, civil status single, again assuming it's significant, no? On the average, single people receive $0.46 less, kasi negative to eh, less than their married counterparts, ceteris paribus. So it's very important to note that these three parameters, these three variables have to be interpreted in the light of the benchmark. Si race white, interpreted siya comparing it to non-white. Si male, interpreted in relation to female. Si single, interpreted in relation to married. So ganun lagi class, no? When you interpret this. And then here, number of dependents, although it's not significant, no? Let's assume it's significant. So on the average, a one person, no? Kasi number of dependents, yung either sons or daughters, no? Or dependents in general. An increase of one dependent, okay, will mean an increase of $0.15, around $0.15 hourly wage, ceteris paribus, although it's not significant. Okay, so let me pause for a while. All right, any questions so far? Kindly chat please if clear yung natin, clear yung interpretation natin ito. No? It's important for us to understand. Okay, good. All right. Before we move on, may isang question ako. Anong interpretation ng intercept, yung negative $3.39? What does that mean? Anyone? What's the meaning now of the intercept, negative $3.39? We go back to the definition. No? The intercept is that value, average value of your hourly wage when all your predictors are equal to 0. So of course, we said that it's even statistically significant. No? Kahit nga hindi statistically significant, sinasama pa rin natin siya sa model. But in this case, statistically significant siya, so all the more kasama yan. But we said that we usually do not put so much emphasis or importance, physical interpretation to the intercept. But it just means that on the average, okay, on the average ano class, married, female, and non-white individuals with no education, no experience, no tenure, and no dependence received $3.39 less than their counterparts. Okay? Actually, hindi na, ulitin ko Okay. Non-white, female, married individuals with no education, no experience, no tenure, and no dependents receive on the average $3.39, negative $3.39 hourly wage. Okay, so how did I get that interpretation? Remember, yung intercept, it's the average value of your dependent variable. So sabi nga natin, wala namang hourly wage na negative 3.39. No? Hindi pa pwede yung respondent pa yung magbabayad dun sa company. Negative kasi. But just for interpretations purposes, walang education, walang experience, walang tenure, walang dependents, tapos zero race white, ibig sabihin nun, non-white siya. Diba? Kailan magiging zero tong race white? Yung non-white. Right? So non-white siya, female siya, married siya. Okay, that's why I said the average hourly wage of a person with no education, no experience, no tenure, who is female, who is non-white, who is married, who has no dependents, is 3.38, a negative $3.39. Okay, let me pause for a while and paki-chat naman please kung clear yung interpretation nun. Kung clear yung interpretation ng intercept na yan. Okay, good. Alright. Importante ang class, naintindihan natin. Okay, so we see here that only there are only some variables here that are statistically significant. No? Remember, ang individual t-test nito, null hypothesis nito is beta null is equal to 0. Ito naman, B1 is equal to 0. B2 is equal to 0. So all of those with p-values less than 0.05, we reject the null hypothesis. All those with p-value greater than 0.05, we fail to reject the null hypothesis. Okay, now this. Okay, 518 degrees of freedom. Saan ang galing yan? Degree of freedom 1 is 1, no? For the intercept. Degree of freedom 2 is n minus k minus 1. What's n? What's n class? 528. Diba? 528 observations. So, ano natin? 526. Minus k. Ilan yung predictors natin? 1, 2, 3, 4, 5, 6, 7. 7 predictors. So 526 minus 7. Hindi natin dito. 526 and row ng wage. Okay. Minus. Ma-minus natin yung n. Ilan yung column ng ano natin? Wage. N column ng wage minus 1. Okay, take a look at how I'm doing it. N column ng wage, ito yung wage natin. Ito. 1, 2, 3, 4, 5, 6, 7, 8. Okay? 8 kaso bawabawasan natin ang hourly wage kasi hindi naman dependent variable to. So N column ng wage minus 1. So that will be your K. Right? So this is N minus K and then minus 1. Ito yung K natin, take note, pinasok ko dun sa loob ng function na to. So, kasi may negative tayo dito kaya ingat lang. No? So this should be 518. 518 degree of freedom 2, which you can see here, ito, 518 degrees of freedom. Right? And then, let's take a look at this. R squared is 37.04. And more important for us is this adjusted R squared, 36.19. So this means that 36%, around 36.2%, 36.19% of the variability of your dependent variable hourly wage can be explained by our model, by our predictors, 36.19%. Now, before, yung model natin dati, ilan lang? Ang kaya lang niyang i-explain is, where's our model 1? Saan na si model 1 natin? Alright. Here, no? Pala. Okay. Summary model 1. Alright. No, 16% lang plus. Okay, versus this one. Na 36.19%. So based on R squared, sabi natin, mas maganda si model 2. Kasi mas kaya niyang i-explain yung variation ng dependent variable natin. Okay? Kaysa iisa lang predictor yung education lang yung gagamitin. Okay? So, why don't we, alamin muna natin class so that we get this already done. Itong 36.19 na to, how was this solved? Okay, if you recall in your ANOVA, analysis of variance, meron tayong tinatawag na SST, which is the sum of the squares total. Okay? Tapos may formula to, no? This is, okay, sinulat ko ba? Wait, let me check. Okay, sorry, hindi ko yata nasulat dito. Okay, hindi ko nasulat. But let me check. This is K32, K23. And then, dito na lang, no? I-share ko sa inyo. Let me just open this. Yun ang kagandahan dito sa sa projects, no? I think I wrote the equation para mas mabilis tayo, no? Did I write it? Is it here? Oh, hindi ko yata nasulat dito. Okay. No. Sorry class, hindi ko nasulat, no? Anyway, i-ano lang natin, no? Okay, let's write it so that we know the formula. We're here. Okay, balik tayo dito. Kailangan natin ng tatlong ng tatlong equation, ng tatlong measures, SST, SSR, SSE. So this is sum of the squares, residuals or error terms. This is sum of the squares, regression. Okay, let's start with this one. Si SST, isulat natin, no? $. Okay. SST is equal to total is equal to y. The difference between your y, small lang, y, and then sub I minus y mean, then squared natin to. Then sum natin. Okay, so take a look at this, class. Yung formula nito, SST is equal to, sa sum natin, yung actual values natin minus the average. Okay? So that's the sum of the squares of your total. And then let's go here to your sum of the squares of your, copy na lang natin to, Control C, Control V. Yung sum of the squares of your regression, okay, is an improvement. No? It's already the improvement in your model. It's your bali, yung ano natin, yung, so may model na tayo, no? Y hat. Okay? This is our predicted value, di ba? Minus the mean. So that's your SSR. So we have generated this regression model. Kukunin natin yung difference ng predicted value minus the average value. Then we square it. That's called your sum of the squares of your regression. Okay? And lastly, ito alam natin to, sum of your squares of your residuals or error terms is the difference between, lagay natin to dito, Control C. Although the order does not matter kasi naka-squared naman siya. Okay, take a look at this, class. Mas maganda sana kung sigma sign to, pero hindi ko na, I didn't bother. And you know, class, iba yung sigma sign. Ba, ito naalala niyo to? Ito, class. Yan, yung sign na yan. Okay, copy na lang natin para mas kompleto yung ano natin. Okay, wait ito yung initial eh. Wait. Okay. Sorry, class, mamaya ako i-decipher to. Medyo ang focus ko yung ano eh. Hindi ako masyado makapag-isip dito. Okay, so SSR, SST, and SSE. So what we need is, gusto natin malaman, paano na-generate itong R squared na to at saka adjusted R squared. Okay, let's compute for this. Okay? Bago tayo mag-compare ng model 1 and model 2. Okay. Kailangan natin si y sub I. Ano yung si y sub I, class? Diba? Ito yung hourly wage, no? Ito yon, yung actual value. So why don't we, to make it faster, let's create this object. Create na lang yung y sub I. yi na lang, no? And it's equal to wage. Tapos i-subset natin yung pang-walo, no? All right, so it's coming from the wage data set, and then it's the 8th. 1, 2, 3, 4, 5, 6, 7, 8. Okay. So we now have this y. This is y sub I. Okay, y sub I to, no? Y sub I. Para mas madali nating ma-ano. And then we have ano lang yung y mean is equal to mean lang, mean ng yi. May NA. May mga missing values ba tayo dito? Let me check, ha? NA. May yi na tayo. Ba't siya nag-error? Not numeric or logical. Not numeric, returning NA. Okay, dali ah. Y mean is equal to, may yi na tayo, di ba? Yi. So this is our yi. Okay, if we get the, ay mali. Sorry. Kasi ang yi natin, okay, sorry ah. Hourly wage yung pangalan ng ano, no? Okay, I stand corrected. So dapat, this should be equal to, okay, sorry. Y mean is equal to mean ng yi and then yun. Okay. Yung hourly wage, no? All right. So may y mean na tayo. Yan, 5.896. All right? Sorry for that. Okay, ano pa kailangan natin? Yung y hat natin. How do we generate our y hat? Pwede natin tawagin ng y mean na lang. So y hat is, saan natin kukunin class yung y hat natin? Sa model 2, right? Yung mga fitted values. Yan. So we're generating this object y hat, and it's coming from, it's from mod 2. May mod 2 na tayo, di ba? Mod 2 fitted values. Bakit? Bakit siya nag-error? All right. Okay, so y hat. Yan. Okay, quick review lang ha. in order to understand yung R squared tsaka adjusted R squared, kailangan natin yung mga formulas na to. SST, SSR, and SSE. Notice it's sum of the squares kasi in-square natin. No? So for example, sum of the squares of the total. It's your actual value minus Y mean. In other words, class, hindi tayo gagamit ng model. Ang base model lang natin, kunin lang natin yung average ni Y, yun na yung value natin, yun na yung predicted value natin. So yung difference siya, yung actual value minus the base model, which is the average. Okay. In other words, we're not going to use the regressors. No? We're not going to use the predictors. Average lang. So no matter what level of, no matter what the observation is, kahit ilang years ng education, experience, kahit na white yan, non-white, or female, ang estimate natin, just get the average of hourly wage. Yun ang predicted value natin, which in this case is 5.896. In other words, regardless of the condition, regardless of the parameters, regardless of the situation, ang estimate natin is that hourly wage will be 5.896. So it will be the same for any situation. Okay, so yun ang Y mean natin. Tapos yung Y hat natin will be, diba, ito yung mga predicted values natin. Ito. In fact, if we do the head na Y hat, yung first 6 values, okay, ito. No? Ito yung mga predicted values natin. And it's different from the Y mean. Ito, yung average class, hindi tayo magmo-model. Kunin lang natin yung average, yun na yung natin, yun na yung predicted value natin. Alright? So let's now compute for our SST, SSR, and SSE. Sige, compute na natin dito. Control-Alt-I. So our SST will be equal to, okay. So sum natin yung, una muna, ano yung formula ng SST? Ito. Yung actual minus the average, di ba? So, yung actual natin is YI minus average natin Y mean. And then what we're going to do there, kaya nga sum of the squares. Square natin to. And then, i-add natin. Sum. Yeah. Okay? So this will be our sum of the squares of your total. Actual value minus the average, square it, and then add natin lahat. This will be your SST. So your SST, sum of the squares of your total, is 7160. Okay, hanapin naman natin si SSR. SSR will be, so it's regression, no? Ibig sabihin, gumamit tayo ng model na generate natin si Y hat. Tapos, i-compare natin siya sa average. Kasi sa average, di ba, wala tayong gagamitin ng predictors, no? Just get the average. See, sum of the squares of the regression naman, we are now improving. So Y hat, small, diba? Small Y hat minus our Y mean. Okay, yung difference nila is actually your improvement. Diba? In-improve natin yung model natin. Kanina, mean lang. Ngayon, may Y hat tayo. Ginamit natin yung mga predictors natin. And then, square natin siya. Okay, and then kunin natin yung sum. Sum of the difference. Okay? So this is now the improvement in the model. Kanina, average lang. Ngayon, may Y hat na tayo. So yung difference ng average at saka ng Y hat model natin is your sum of the squares of your regression. Or this is also your explain. Yun na-explain natin ng, the others call this SSE, sum of the squares, explain, no? Sum of squares, yun na-explain natin kasi gumamit tayo ng regression. Okay, and finally, meron tayong SSE. Okay? SSE yung yung hindi natin na kayang hindi natin na kayang i-predict, no? So that's the difference between your y sub I, si y sub I natin, minus si y hat. Okay, so ito yung hindi na kaya natin na predict. So gagawin ulit natin dito, i-square natin siya, no? Square natin, tapos kunin ulit natin yung sum nila. Sum of the squared differences between your actual value and your predicted value. Di ba ito yung residuals natin, no? Alright, so enter natin. So we now have these three values. Our SSE, SST, and SSR. Yan. Naran ko naman ito, SSR. Alright, SSE, and notice that your SST is actually SSR plus SSE. Kung isum up natin yan, SS, sum of the squares of your regression, yung explained, sum of the squares of your errors, yung unexplained. No? So this is sum of squares, explained, and unexplained. Explained kasi gumamit tayo ng regressor, so we were able to improve on our prediction instead of just using the mean. No? Unexplained naman, yung difference ng actual value at saka ng predicted value natin. If we add the two, okay, 71604.4, it's the total, sum of the squares of your total. Okay, so the sum of the squares of your total is actually equal to my portion doon na na-explain natin using the regression and my portion doon na hindi natin na-explain, which is your residuals. All right. So in order to compute for I, so therefore, dito na tayo, no? So we're now computing for your R squared. Eh, di ba? Ito yung proportion explained by our model. Okay. Proportion explained by our model. So let's call it R squared. No? R squared, alt minus, oops, mali. Oh. Control Shift. Yeah, Control. Kalimutan ko dagdag. Plus ano yun? Kaya yung kapag ginagawa to. I'm having problems with my keyboard. Okay, ano yung R squared natin? Okay, it's your SSR, yung sum of the squared ng regression, yung na-model natin, divided by sum of the squares of your total. Yan, ganun lang ka-simple, class. So SSR over SST. So, i-run natin yan. So what's our print natin R squared? 37.04. Okay, ano lumalabas dito sa overall goodness of fit test? Ayun, 37.04. So itong multiple R squared na yan, dun nang galing yan. Okay? So ang sinasabi dyan, na kung mean lang yung inano natin, kung ang hindi natin itong ginamit ng mga ano natin, yung mga predictors natin. Okay? And we just stuck to the mean. Ang mean natin kasi 5.86. And then we modeled hourly wage using these predictors. We would have been able to explain 37% of that. Okay? And we were able to prove that, no? Yung R squared natin is yun, 37.04. Now, meron pang isa, no? Yung adjusted R squared. Okay. Kasi, Diba? Pwede natin sabihin na, edi, dagdagan natin lagi yung predictors natin. Kasi every time you add to the predictor, ang mangyayari niyan, tataas yung adjusted R-squared. Okay? But that's not the basis. Kasi, pag nagdadagdag tayo, what if we add 100 predictors? Diba? Is that an efficient way to do it? Hindi. So that's why, meron tayong formula na tinatawag na adjusted R-squared. Lagyan na natin dito, I'll call it R squared adjusted na lang, no? And the formula for that is, pinapenalize natin yung 1 minus, so 1 minus R squared. I'm just writing the formula. And then times, so this is n minus 1, and then divided by n minus k minus 1. All right. So ito class yung formula for adjusted R squared. Notice na every time na nagdadagdag tayo ng predictor, what will happen? When we keep on adding to the predictors, what will happen to your denominator? No? Liliit to, diba? Liliit tong denominator na to. So what will happen to your numerator? What will happen to this whole expression? This whole expression will become bigger. No? Pag lumaki to, liliit yung adjusted R squared natin kasi 1 minus yan. Right? So that's the main thought behind this, adjusted R squared. We are penalizing the model for adding more regressors. So gawin natin to. Sige. Let me just call it R2 adjusted na lang, no? Alt minus. So it's 1 minus, almost time na pala, no? 1 minus, di ba, R squared. R squared. And then times n minus 1. Ano yung n natin? N row na lang. N row ni wage. Di ba? Number of rows ni wage. And then, minus 1 yun, no? N minus 1. Number of rows minus 1. And then divided by itong n minus k minus 1. Ingat na naman tayo dito. No? So let me put it in a bracket na lang, no? Para clear. N row ni wage minus, so this is your n. Yung k natin, okay, again class, ang k natin is yung number of predictors natin. Let me just use the n column. N column of wage. Yung n column kasi ni wage, kasama si dependent variable, no? So ima-minus 1 ko siya. Mas maganda sana kung nag-create tayo ng isa pang object na wala yung dependent variable natin. Tapos minus 1. Okay, take a look at my formula. I hope it's not that confusing. So ito yung n plus n. Yung k natin is the number of columns of your wage minus 1. Kasi yung wage data set natin, 8 yan yung column siya. Kasama yung dependent variable natin. So bawasan natin kasi ang predictors lang natin 7 lang. No? And then minus 1. Okay, so let's see. Tama na ba to? Para may mali daw. 1 minus this 1, 2, 1, 2. Anong kulang dito? This 1, 2, 1, 2. Ayaw ba niya to? Parang ayaw niya yung bracket. Yan. Ayaw niya ng bracket kanina. Sige. So ito class, let's see. Print natin R2 adjusted. 36.19. Tama ba? 36.19. Yun, plus. 36.19. Yan. All right. So we were able to show that indeed yung adjusted R squared natin is 36.19. So ano ginagamit dyan, class? Is it the R squared or the adjusted R squared? Ang mas relevant, class, yung adjusted R squared. Okay? All right. It's time already, class. Let me just do one last test here. No? Control Alt I. Then, di ba may model 1 tayo? Ang model 1 natin, isa lang yung predictor natin. Di ba? Ito. Si model 2 natin, marami tayong predictors. So what we can do is to check ANOVA. No? Mag-test tayo ng ANOVA, model 1 versus model 2. Now, ang hypothesis dito is H null. The restricted model is better than the unrestricted. Okay, let me explain. Pag sinabing restricted, mas konti yung predictors. Restricted. Unrestricted, yung mas marami. So here we're testing, sino mas maganda? Si model 1 o si model 2? Si model 1 natin yung restricted. Diba? Si model 2 yung unrestricted. Okay. Now, in terms of R squared, kita natin na mas maganda si model 2 kasi 36.19 yung ano niya, yung adjusted R squared. Si model 1, ilan lang? 16 point something lang, di ba? So, mas kayang mag-explain ni model 2, no? Yung variability ni model 1. But let's do this and let's have a statistical test for this. Okay? So, using ANOVA, analysis of variance, tingnan natin, run natin to. All right. Check, class. This is the result. Focusing on this, the p-value, statistically significant. Therefore, ano conclusion natin? Ano conclusion natin? Degree of freedom, okay, ni model 1 is, ito yung si model 1, 7, no? Okay. 524 degrees of freedom, ito si model 1. Mas marami siyang degree of freedom. Degree of freedom ni model 2, 518. So, anong conclusion? P-value is less than 0.0. Therefore, we reject the null hypothesis that the restricted model, which is model 1, yung mas konti, is better. Okay, mali. Mas maganda si model 2, yung unrestricted, yung mas maraming predictors based on this statistical test. Okay? All right. So let me stop there, class. Next meeting, we're going to continue with this model, no? Titingnan natin kung kasi may mga ano pa tayo, no? May mga predictors na hindi pa significant, no? So anong gagawin natin diyan? Hindi pa pwedeng tanggalin lang natin lahat 'yan. We do not do that. We do what we call a stepwise regression. One at a time, tatanggalin natin yung mga insignificant variables dito and see what happens to our model. All right? So next meeting, when you come to class, kindly have this file already ready, class. We will continue with the next parts, which is titingnan natin yung ano na, yung compare naman natin, magtatanggal tayo ng variable, no? Tapos ano yung tatanggalin natin ng variable until such time that lahat ng mga predictors natin significant. Kasi dito may mga insignificant tayo. So magtatanggal tayo dito. All right? So let me stop recording.